Alright, so welcome back to section B. The first question here says, the Bureau of Meteorology have asked you to assist in determining which of the variables collected would be a better predictor of maximum temperature. Let's start with our analysis of hours of sunlight against maximum temperature. Okay. So please be aware of the fact when it says against, okay, when this statement here says against, it's implying that maximum temperature will be on the y-axis, or it's the response variable. So what we need to do is we need to go to our data and actually before we even go to our data, let's just make sure that all our key paths are, so this is going to be sunlight and this is going to be max temp. Please make sure you always check this out before you even do the scatter plot, because if you get the response variables and the explanatory variables mixed around, you will pretty much mess up everything. Okay, so I'm not going to bother drawing this up at the moment, but all you got to really do is just plot the points. Give me a second. You just got to go to your data, maximum temperature versus... so you want to use this data. Okay, so the two, purple's a terrible color, let's try this. You want to use these two columns and actually drawing up this data. Okay, so you want to use these two light blue columns and actually making sure that you pair up, so you go across 4.5 and you go up to 14. Go across to 5.3, go up to 15.9, go across to 2.3, go up to 13.7. And you should get, after you plug in all those points, something that looks like this. Magic. Okay. The next question says, determine the least squares regression equation for this association in terms of the explanatory variable and the response variable. So the way I determine what the least squares regression line is by actually plugging in the data, and we're going to go through regression analysis here. So this is going to be sunlight, and the next one's going to be max temp. Sunlight and max temp. So let's go to our data, sunlight, paste, and max temp. Paste. Alright, so now that I've input my data, make sure they're all aligned. So in other words, the first value has to correspond with the first value there. We're going to form the least squares regression line now. So menu, actually, control, menu, quick graph, control 6, control right, and we should put the explanatory variable as sunlight. And max temp goes in the y-axis. And we'll go to menu, analyze, regression, and number 2. So menu, analyze, regression, 2. And you have got your least squares regression line right there. Now you'll notice the R squared value comes up. On your CAS, if it doesn't come up, this is what you need to do. So some of you guys will get this. You need to go to menu, settings, and click this diagnostics button. Now go make default, and so now every time you're going to create the least squares regression line, your R squared value will come up. If your calculator doesn't come up with number 6 settings, it means that your calculator is out of date, which means that you'll need to get it updated from your teacher. Okay. Alright, so we've got to actually do the line of best fit now. So we've got y is equal to, I'm going to do maybe 3 decimal places for now, just to see what we can round it to. So 13.818 plus 0.241 x. Okay. Now we need to make sure that we always express the least squares regression in terms of the response and explanatory variable. Okay. So I'm going to change this to max temp is equal to. Now, you need to be consistent with your rounding. Okay, so if you're going to round one as, for example, 3 decimal places, you need to make sure you round the other as 3 decimal places as well. So 0.241 times the sunlight hours. Okay, and we've got our least squares regression line, and just for a bit of an extra sort of piece of feedback, the RV goes here and the EV goes there. Okay, draws the least squares regression line on the scatter plot. So the least squares regression line will need to be drawn. Now, this is a common mistake with students, that they just assume when you draw the line of best fit. This is a method that we have taught in the past, where we say by inspection, okay, because you wouldn't draw the line of best fit going, going this way like this. Okay, you wouldn't draw the line of best fit looking like this. Okay, so we do tell you in the previous years to actually approximate this, but there's a proper way of doing this. So what you need to do first is, on your data point, you need to choose 2 points on your graph. Okay, the 2 points I'm going to choose, because I like the values of this, are 0 and 10. Okay, so 0 and 10. So what I'm going to do is I'm going to plug in 0 into the equation, and I'm going to plug in 10 into the equation. So I'm going to plug those 2 values into here, into where the EV is. And I'm going to see what comes out when I plug those values in. So I'm going to start a new page, or new tab. So we get 13.818 plus 241 times 0. And I'm going to do the exact same thing. For those of you that are wondering how I did that and copied and paste, you go up, up, and then enter. And then you get 10 hours. And so, if I plug in 0, I get 13.818. And if I plug in 10, I get 16.228. Which means that I can go onto my graph now, and 13.88 is around that area. 16.288 is around this area here. Now that I've got my 2 points, I'm actually going to forget about all the dots that are in here. I'm just going to connect these 2 dots. Okay, and obviously I don't have a ruler, it's not going to be completely straight, but obviously you will have a ruler. And you've drawn your line of best fit. So if you ever see a question that says draw the least squares regression line, this is the correct way to do it. Find 2 points, join and extend them. Don't just do it by inspection, because you will not achieve the mark for that. Okay, next question. Determine the correlation coefficient and interpret it in terms of strength, direction, and assumed form. So there's 2 ways we could calculate this. Okay, there's 2 ways we could calculate this. I'm going to do it the first way by using the R squared value. If the R squared value is 0.12900, okay, to find the R value, we find the square root. So we find the square root of 0.12900, and R will give us 0.12900, and we get 0.35917. I'm going to do it to 5 decimal places, but later on we'll see how we go for that. So actually, maybe let's do 2 decimal places. That's one way you could do it. Okay, the other way you could do this is by going onto your data sheet, which is here. After you go onto your data sheet, you could go menu, statistics, stat calculations, 2 variable statistics. Your X list is sunlight, and your max temp is your explanatory variable, response variable. And you can scroll down, and you can get your R value, which is right there, 0.3917. So 0.35917. So you can do it that way. Or Also, I need to make note that whenever you take the square root, there's a plus or minus that you need to consider. Since the graph is going up in a positive or upward trend, we only consider the positive component. The other way you could do this is by going onto your new calculator page. So you can go Control, New Page, Add Calculator, and click on this var button. If you click on this var button, you just scroll down until you find something that says Stat R, and enter, and you get 0.35917 as well. Okay. Alright, so you've got to interpret in terms of strength, direction, and assumed form. Strength is, I think it's weak. Okay, according to the templates. Weak, the direction is positive. Okay, and we make assumptions that it is linear. Okay, if there's a curve to it, okay, we still assume the data is linear, because otherwise we won't be able to use the correlation coefficient. That's one of the assumptions that it makes. We have to assume that it's linear. If not, then there'll be further analysis from there. Okay, the next one says sketch a residual plot based on the regression line below and comment on what the residual plot shows. So we need to go back to our graph here. Our graph, okay, and we need to find how can we turn this graph into a residual plot. So to turn this into a residual plot, menu, analyze, residuals, and show residual plot. This is what you need to plot down. Now I'm going to anticipate some errors that you guys might see. You might see that at this point, if you try to do the residuals, it still pops up. But if you don't have the regression line, so I'm actually going to take this regression line out. Some of your calculators will not allow you to calculate the residuals if you don't have the regression line. So you can see with this one, the option 7 is grayed out. So you need to make sure you always have the regression line present before you do the residuals. Residuals, show residual plot, and you have to understand I'm doing this on the computer. You can do this by hand. Actually, I should probably get rid of that. So you need to make sure that when you do your residual plot as well, you've got some sort of label here. Okay, so this is from up to 4, this up to -4, that's 0, and we're talking about the residual here. Okay, and the plot is as shown. Now keep in mind it says, comment on what the residual plot shows. Okay, so whenever you're asked to comment on the residual plot, you need to make sure that you state if there is a clear distinct pattern or if there's no distinct pattern. So the residual plot shows no distinct pattern, which implies that the association is linear. Okay. If there was a pattern, so hopefully you remember this from your notes, if the pattern looked like this, if the dots look like this, like a U shape, or if the dots look like this, even upside down U shape, okay, or even some indication that it looks like that, then you would say that the association is non-linear. So you would just change this word to non-linear, and you would change this to it shows a distinct pattern. But in this case, it doesn't show a distinct pattern, so we're good. Right, we're nearly there. Determine the coefficient of determination and discuss its interpretation. Luckily, our R-squared value is already there. So R-squared is equal to 0.129. And if you don't like doing that, you can go calculator page, var, you just find the one that says R-squared, and you've got the same R value there. Now, when it says discuss its interpretation, you need to please make sure you use the template that you're given. That's not the problem. Which graph? Interpreting templates. So it says interpret the coefficient of determination. So we're going to use this template, and this will hopefully be in your books. Okay, so let's plug in what we need to plug in here. It says R value expressed as a percentage. So I'm going to change this to 12.9%. Okay, so 12.9% of the variation in the insert response variable. So the response variable was maximum temperature. Can be explained by the variation in the explanatory variable. So the explanatory variable for this one is the hours of sunlight. And guess what? Full marks. Alright, let's get going on. Identify the explanatory variable from the above equation. This one here is the explanatory variable. Wind speed. No questions asked. Okay, because that one, if you change this, this will change. Okay, so this one responds to whatever changes happens here. So wind speed is the explanatory variable. Identify and interpret the slope of the least squares regression line in terms of wind speed and maximum temperature. Again, go to your templates, interpreting the slope, because that's what the question's asking for, interpret the slope. So I'm going to copy and paste this. This should be in your book. Alright, on average, the response variable, okay, I'm going to write, might as well write it here. This is RB, and this is EB. The, what was it? The maximum temperature is predicted to increase. The reason why we say it's increase is because there's a positive there. If it was a negative, we would say decrease. So increase by value of B units. So what's the value of B? The B is this value, so 0.0173 units for each 1 unit increase in the wind speed. Okay. And let's make sure that we change this units to whatever units it is, so degrees. Okay. And you're done with the question. If you want to be specific, 1 unit, so wind speed is measured in kilometers per hour, so you would change it to kph as well. Oh, and I should probably identify what the slope is, so B is equal to 0.0173. Alright, nearly there. Same thing. Identify and interpret the y-intercept of the least squares regression line. So go to your templates. I'm going to use the top one. Doesn't matter if you use the top or the bottom one. Okay. It is predicted that when the value of the explanatory variable is wind speed, so I'm going to say wind speed is 0 units. So in this case, kilometers per hour. The value of the, so wind speed, I'm going to change this to maximum temperature. The value of the maximum temperature is, insert the value of A. So the value of A is the y-intercept, so 14.4. 14.4 degrees. Okay. All right, moving on. We got these last few questions here. Now, using your equation provided in number 6, predict the maximum temperature on the 1st of August. So we're going to use this equation. I'm going to copy and paste this just because I am. 1st of August. So this is the next piece of data, so August 2019. And remember the data, we're looking in July. So we need to make sure we do I guess you could say, the next value here, which will be, oh, actually, no, never mind. Scratch what I just said. On August, predict the maximum temperature. So we're going to plug this value, 8, because it says predict the maximum temperature. So we're trying to work out what this value is. Plug this into here. So we get 14.4. So 14.4 plus 0.0173 times whatever we plug in, which was 8. And we get 14.54 degrees. Okay, so 14.54 degrees. Now I'm just going to round this to perhaps maybe 14.5 degrees. Okay, or if you have used 2 decimal places for the earlier ones, it doesn't really matter at this point. So that is my prediction. Okay, that's my prediction. The next question says calculate the residual value. Now remember, residual is actual minus predicted. So the actual value is 13.8. But we predicted it to be 14.54. So it's actually less than what we predicted, which means that our residual should be negative. And if we calculate this, 13.8 minus 14.54, we get negative 0.74, which is our residual value, which means that it's under what we predicted. Now, it says here, comment on the reliability of this prediction and explain why. Not reliable. As we are extrapolating, predicting outside of the given data set. Okay, because we're given only the data for July, we're extrapolating. We're using that data to predict something in the future, which is not reliable. Okay. We're on to the last question. It says, based on the analysis, which variable, hours of sunlight or wind speed, is a better predictor of maximum temperature and why? So if we find the actual R squared values and R values, we find the following. So this is sunlight, and this is wind speed. We can calculate the R and the R squared values. Okay, the sunlight value that we, these are given in the question. So the sunlight, so where is it? Sunlight, so maximum temperature and wind speed is 0.0126. 0.0126. And the sunlight one that we calculated a while back was 0.129. Okay, because that's where we calculated that. Here, this value here, the R squared value. So from here, we can actually calculate the R values from this. So we find the square root of 0.129, or we find the square root of 0.0126. And we calculate the correlation coefficient for this one is 0.35 or 0.36, and this one here is 0.11. So I would actually say sunlight is a better predictor of maximum temperature, as it has the higher R squared, R and R squared value. Okay, and I just quote what they actually are. 0.36 and 0.129. Alright, and that concludes the working out of the 2020 SAC that was done. Now you'll notice a particular trend, and your teacher will talk to you about this, but all the questions here do not have mark allocations. Unfortunately, this is the VCAR requirements that we have to adhere to. However, your teacher was going to provide you a vocab list of potential cues that you might see. So for example, if you are ever said to choose an appropriate display, actually I'm going to make another video on this one. We'll watch another video in a moment.